A-level statistics, probability distributions. To explain probability distributions, we first need to define what we mean by a discrete random variable. For example, if we throw 5 dice and count the number of sixes, the number will have a value that is an integer between 0 and 5. This is an example of a discrete random variable. A discrete random variable is a variable that can only take certain individual values, each of which occurs with a given probability. We usually refer to such a variable with an uppercase letter such as capital X. In the above example, X can take the values 0, 1, 2, 3, 4 or 5, and so we say X is an element of the set containing the numbers 0, 1, 2, 3, 4, 5. Then P in brackets X equals 1 means the probability of getting 1 6. If we can calculate the probability of each random variable, this is called a probability distribution, and it can be put in a table. So for example, 5 coins are thrown. Draw a table for the probability distribution of the number of heads showing. Well, to solve this, the random variable X is the number of heads showing, and we have X can take the values from 0 to 5. So X is an element of the set of numbers between 0 and 5. We can show the probability distribution on a table. Now in the first row we have the possible numbers for X, 0 to 5. And then in the second row we have the probability of each of those numbers occurring. So the probability of getting no heads is 1 over 32. The probability of getting 1 head is 5 over 32. The probability of getting 2 heads is 10 over 32. And for 3 heads it's 10 over 32. For 4 heads it's 5 over 32. And for 5 heads it's 1 over 32. Now I haven't shown you how those are worked out. In this section we'll see how the probability distribution can be calculated in different situations. Note, an important fact is that the sum of all the probabilities in the distribution must be 1. One of the outcomes must happen. So, for example, in the following distribution, find the value of k and find the probability that x is less than or equal to 2. Well, to solve this, we know that the sum of all the probabilities must be 1. And that tells us k plus 2k plus 3k plus 4k plus 5k plus 5k is equal to 1. So 20k is equal to 1, or k is equal to 1 over 20. Now, for x to be less than or equal to 2, x could equal 0 or 1 or 2. So the probability that x is less than or equal to 2 is equal to the probability that n is equal to 0 plus the probability that n is equal to 1 plus the probability that n is equal to 2, which from our table is 1 over 20 plus 2 over 20 plus 3 over 20, which is equal to 6 over 20, or 0.3. And so the probability that x is less than or equal to 2 is 0.3. In another example, we're told, from a group of 3 girls and 7 boys, a team of 4 must be selected at random. If G is the number of girls selected, draw a probability distribution table of G. Well, to solve this, the possible values of G are 0, 1, 2 or 3. There's a maximum of 3 girls. So if G is equal to 0, we must select 0 girls out of 3, which is 3C0, and 4 boys out of 7, which is 7C4. So the total number of selections is 3C0 times 7C4. And the total number of selections altogether is 4 children out of 10, which is 10C4. So the probability of getting no girls is 3C0 times 7C4 over 10C4, which is 1 times 35 over 210, or 35 over 210. This cancels to 1 over 6. Now the probability of getting one girl means we've got to select one girl out of 3 and 3 boys out of 7. So that's 3C1 times 7C3 over 10C4, which is 3 times 35 over 210, which is 105 over 210. This cancels to a half. Now the probability of getting 2 girls means that we've got to select 2 girls out of 3 and 2 boys out of 7. So that's 3C2 times 7C2 over 10C4, which is 3 times 21 over 210, which is 63 over 210. This cancels to 3 over 10. Now the probability of getting 3 girls means we've got to select 3 girls out of 3 and 1 boy out of 7. So it's 3C3 times 7C1 over 10C4, which is 1 times 7 over 210, or 7 over 210. This cancels to 1 over 30. And if we put those in a table, that gives us our answer. Let's have a look at a similar example. From a bag containing 8 red marbles and 4 green marbles, 5 marbles are selected at random without replacement. Draw a probability distribution table for the number of red marbles chosen. Well, if R is the numbers of red marbles, then R can take a value from 1 to 5. It can't take the value 0 because there's only 4 green marbles, and therefore at least one of the marbles must be red. Now, the probability that one of them is red means we've got to select 1 red out of 8 and 4 green out of 4. So that's 8C1 times 4C4. And the total number of choices, well, there are 12 marbles and we're selecting 5. So that's over 12C5, which gives us 8 times 1 over 792, or just 8 over 792, which cancels to 1 over 99. Now the probability of getting 2 red marbles is the choice of 2 out of 8 red marbles and 3 out of 4 green marbles. So it's 8C2 times 4C3 over 12C5, which is 28 times 4 over 792, or 112 over 792, which is equal to 14 over 99. Now the probability of getting 3 red marbles means we've got to select 3 out of 8 red marbles and 2 out of 4 green marbles. So it's 8C3 times 4C2 over 12C5, which is 56 times 6 over 792, or 336 over 792, which cancels to 42 over 99. Now, to get 4 red marbles, we have to take 4 out of 8 red ones and 1 out of 4 green ones. So it's 8C4 times 4C1 over 12C5, which is 70 times 4 over 792, or 280 over 792, which cancels to 35 over 99. And the probability of getting 5 red marbles means we've got to take 5 out of 8 red marbles and none out of 4 green marbles. So that's 8C5 times 4C0 over 12C5, which is 56 times 1 over 792, or 56 over 792, which cancels to 7 over 99. And we can put each of those answers into the table to complete it. Let's see what we mean by the expectation of a discrete random variable. Suppose a dice has the numbers 1, 1, 1, 2, 2 and 3 on its 6 faces. When we throw it, we'll have the possible outcomes x with the probabilities shown in the table. The numbers 1, 2 or 3 can show, and the probability of getting a 1 is 3 out of 6, the probability of getting a 2 is 2 out of 6, and the probability of getting a 3 is 1 out of 6. If we were to throw the dice 600 times, we would expect to get a 1 300 times, a 2 200 times, and a 3 100 times. We would expect our total score for the 600 throws to be 1 times 300 plus 2 times 200 plus 3 times 100, which is 1,000. So our expected mean score, that is the mean score per throw, to be 1,000 over 600, which is 1 2/3. Now we can get the same result if we sum the product of each variable with its probability. So we go 1 times 3 over 6 plus 2 times 2 over 6 plus 3 times 1 over 6, which gives us 3 plus 4 plus 3 over 6, or 10 over 6, which is 1 2/3. So we call this mean the expectation of x, and it's equal to the sum of the xp's, where x is the variable and p is its probability. The variance and standard deviation of a discrete random variable. We can use the variance and standard deviation of a discrete random variable as a measure of its spread. Now, if we have some general group data, we can say the variance is equal to the sum of the x squareds times their frequency over the sum of the frequencies minus the mean squared. So the variance for a discrete random variable can be written as the sum of the x squareds times their probability over the sum of the probabilities minus the mean squared. But the sum of the probabilities is equal to 1, and so the variance is equal to the sum of the x squareds times their probabilities, p, minus the sum of the xp's, all squared. And the standard deviation is the square root of the variance. So in the previous example, the variance is 1 squared times 3 over 6 plus 2 squared times 2 over 6 plus 3 squared times 1 over 6 minus 1 2/3 all squared. So that's 3 over 6 plus 8 over 6 plus 9 over 6 minus 25 over 9, which is 20 over 6 minus 25 over 9, or 30 minus 25 all over 9, which is 5 over 9. So the variance is 5 over 9, and the standard deviation is the square root of that, which is root 5 over 3. So remember, the expectation of x is the sum of the xp's, the variance is the sum of the x squared p's minus the sum of the xp's all squared, and the standard deviation is equal to the square root of the variance. Let's have a look at a couple of examples. In the first one, we're told the probability distribution for a random variable x is given in the table, and we're asked to find the value of m. Now we know that the sum of the probabilities have to add up to 1. So, looking at the bottom row, 0.1 plus 0.15 plus 0.2 plus 0.4 plus m is equal to 1. Or 0.85 plus m is equal to 1, and so m is 0.15. Now in part B, we're asked to calculate the expectation and variance of x. Now the expectation is simply the sum of the xp's. So the expectation is 1 times 0.1 plus 2 times 0.15 plus 3 times 0.2 plus 4 times 0.4 plus 5 times 0.15, which is 0.1 plus 0.3 plus 0.6 plus 1.6 plus 0.75, which is 3.35. Now the variance is the sum of x squared times its probability minus the mean squared. So it's 1 squared times 0.1 plus 2 squared times 0.15 plus 3 squared times 0.2 plus 4 squared times 0.4 plus 5 squared times 0.15 minus 3.35 squared. Now this is 0.1 plus 0.6 plus 1.8 plus 6.4 plus 3.75 minus 11.2225, which works out to be 1.4275. So the expectation is 3.35 and the variance is 1.4275. In the second example, 3 balls are selected from a bag containing 5 red and 2 blue balls. Now in part A, we're asked to draw a probability distribution table for the number of blue balls. Well, if there are no blue balls, we're selecting no blue balls out of 2 and 3 red balls out of 5. So that's 2C0 times 5C3 over, and in total we're selecting 3 balls out of 7, so that's 7C3, which gives us 1 times 10 over 35, or 2 over 7. Now to get 1 blue ball, we've got to select 1 out of 2 blue balls and 2 out of 5 red balls. So that's 2C1 times 5C2 over 7C3, which is 2 times 10 over 35, which cancels to 4 over 7. And to get 2 blue balls, we've got to get 2 blue balls out of 2 and 1 red ball out of 5. So that's 2C2 plus 5C1 over 7C3, or 1 times 5 over 35, which is 1 over 7. And so we can fill in the table. The number of blue balls can be 0, 1 or 2, with probabilities 2 over 7, 4 over 7 or 1 over 7. Now in part B, we're asked to calculate the expectation and the variance of B. Now the expectation is simply the sum of each number multiplied with its probability. So it's 0 times 2 over 7, plus 1 times 4 over 7, plus 2 times 1 over 7, which is 6 over 7. And the variance is 0 squared times 2 over 7, plus 1 squared times 4 over 7, plus 2 squared times 1 over 7, minus 6 over 7 all squared, which gives us 4 over 7 plus 4 over 7 minus 36 over 49, which is 20 over 49, and so we have an expectation of 6 over 7 and a variance of 20 over 49.